Good morning, everyone. Thank you for giving me this opportunity to present my paper in 4th International Conference on Electrical and Electronics Engineering. My topic is Photovoltaic with Battery and Supercapacitor Energy Storage System for Better Performance, Devices and Modeling. My paper ID is 474 and my track is Renewable Energy Sources and Technology. There are two authors. I am Somesh Kede and my co-author is Prajakta Vaidya. In content, we will see introduction, photovoltaic, battery energy storage system, supercapacitor energy storage system, problem identification, then why we need of energy storage system, block diagram, then the result, and last one is conclusion. In introduction part, by reducing greenhouse gas emissions in smart grids and electric cars, lithium-ion batteries can help society achieve its low carbon and environmentally sustainable goals. Electric vehicle development is being hampered by technological obstacles caused by challenges with battery system durability, lifespan, and safety. Battery power capacity is strongly limited by performance degradation and capacity decay issue. It is important to manage the energy storage system to condense the key issue with battery management systems. To overall all the problems, we have an energy storage system that combines battery and supercapacitor technologies that offers several benefits to the system. What is photovoltaic? It is a device with technology that permits the direct conversion of the solar energy into electrical energy. It is a semiconductor material based device used to convert sun energy into electrical energy is called a solar cell or a photovoltaic cell. The physical phenomenon of converting the sun energy into electrical energy is also known as the photovoltaic effect. Battery energy storage system. Battery energy storage system is one of the most widely used storage system in photovoltaic system. It stores excessive energy generated by the photovoltaic system during the day and releases it during the night or during the period of high energy demand. The energy stored in the batteries can also be used in the event of power outage. Now we are moving towards the supercapacitor energy storage system. What actually is supercapacitor energy storage system is a new technology that becoming increasingly popular in photovoltaic system. Supercapacitor energy storage system can store and release energy much faster than the batteries. Supercapacitor is also known as ultracapacitor or electrochemical capacitor. They store energy electrostatically rather than chemically, allowing for rapid charge and discharge cycle and high power density. Problem identification. We will see the battery can storage energy, and the main problem with the battery system mileage, longevity and safety have turned into technical something that slow down the progress that is limiting the development of electric vehicles. The performance degradation and capacity decay phenomena severely limit the power capacity of batteries. To summarize the main issue with the battery management system, it is extremely important to control the energy storage system. So to overcome all the problems, we can use the combined energy storage system for an efficient system. Here why we need of energy storage system. Energy storage technology has the potential to moderate numerous challenges currently facing the electrical industry and consumers. First of all, thirst for renewable energy sources, then the variable outputs, energy reliability, improve the uniformity and efficiency of the system, and its improve electrical system performance. In block diagram, we will see modeling of photovoltaic with battery and supercapacitor energy storage system. Consider the electrical connections and control mechanism between the battery and the supercapacitor. Here electrical connections and control mechanism of the system. Here are the key aspects of electrical connections and control mechanism between photovoltaic system, battery and supercapacitor. we will see the electrical connections. PV array to battery, battery to supercapacitor, supercapacitor and battery to load. Now in orange and black color, this is the PV array. Now in blue color, this is the DC-DC boost converter. Then it will going towards connected to one of the bidirectional DC-DC converter supercapacitor and bidirectional DC-DC converter battery. They both are the hybridly connected to the photovoltaic system. Now we will see control mechanism. Energy management system, charge controller, DC-DC converter. In energy management system, the photovoltaic system, battery with supercapacitor are under the supervision of energy management system. The energy management system monitors the state of charge and state of health of the battery and supercapacitor as well as the photovoltaic array's output. Based on the information and predefined algorithm, the energy management system determines the optimal distribution and utilization of energy between the battery, supercapacitor and the load. Now, charge controller. The controller that controls the charge is necessary for controlling how the battery is charged in the order to avoid overcharging or undercharging, which can reduce battery performance and longevity. It makes sure that the battery receives the proper voltage and current from the PV array. Now DC-DC converter. The converter DC-DC between the battery with supercapacitor manage the energy flow and ensure efficient transfer between the two storage devices. It controls the charging and discharging process, allowing energy to be transferred based on the system needs and performance requirements. These electrical connections and control mechanism enables the seamless integration of photovoltaic system, battery and supercapacitor. The coordination between these components ensure efficient energy harvesting from the photovoltaic array, optimal storage and discharging of energy using the battery and supercapacitor, and effective management of energy distribution to the load. The control mechanism play a vital role in maintaining system stability, maximize energy utilization and extending the lifespan of the storage devices. At various irradiance measurements from the PV array, the characteristics between current and voltage explain the voltage, current and power voltage characteristics. The irradiance values on the module validate the array's operation and are calibrated in kilowatt per meter square. The highest power is at 1000 irradiance when the current reading is 8 ampere and the voltage is 21 volt. We have array module data. The maximum power of array module data is 120.7 watt and 72 cells per module. And we have a rated capacitance, supercapacitor with 29 farad and battery with 14 ampere hour. In this diagram, we will see merits and demerits with battery and battery with supercapacitors. In battery energy storage system, we will see the constant current, it's charged slowly and discharged rapidly. While we are using battery plus supercapacitor, it gives 3 to 6x more use time and charge speedily and discharge slowly. Result, we will see behavior of voltage and current of supercapacitor. In this figure, supercapacitor waveform shows the initial voltage 32 volt, current 0 to 10 ampere, state of charge 98.9 to 99% and power is 0 to 500 watt. Simulations may show the outcomes and systems effectiveness in fulfilling the load's energy requirements and considering the input factor. The real output voltage reaction is simulated in simulation, current, state of charge, power of supercapacitor for supercapacitor. On x-axis time 0 to 4 seconds, on y-axis it shows voltage, current state of charge and power calculations. Now we are looking to the response of voltage and current of the battery. This figure shows battery response with voltage, current, state of charge and power calculation of the battery. This shows the battery response with the voltage 25 to 26.5 volt, current 0 to 10 ampere, and state of charge is 50% for the battery. On x-axis we will see the time in seconds, 0.1 to 0.4 second. On y-axis we will see the voltage, which is 24 volt. Then current is 10 ampere, and then is state of charge, which is 50%, and then power calculation, which is minus 500 to plus 500. The outcome shows that overall control techniques effectively regulated the power flows between system components in the model. As a result, establishing the requirement balance made the variable load demand and preserved DC voltage stability. In the conclusion, the outcome shows that the overall control techniques effectively regulated the power flows between system components in this model. It can be determined from the analysis and discussion finding from the design and modeling of PV integration using the simulation tools MATLAB Simulink. And the combined energy storage system modeling approach not only enhances system performance but also promotes the utilization of renewable energy sources and reduce conventional grid infrastructure. We concluded that the system enhancing the system performance and balance the energy and preserve the voltage stability and utilization of the renewable energy sources, and the system become more sustainable and it's becoming eco-friendly or environmentally friendly.